Okay, today we're going to look at lesson 17B. Again, this is another part of that same section in your textbook, and this homework goes along with homework 17A. So your I can statement or learning objective is I can solve systems using elimination. So the difference today is that you're either going to have to multiply one or both equations, and I'll show you how to do that. Here are some important things that we need to note before we get started. You're going to use the same steps from 17A. We're not going to write those down again. If you didn't write them down before, you might want to go back and watch that lesson 17A video, write those steps down, and then come back. Next, you're going to have to make one of the variables have matching coefficients. So before, something already matched. It was ready to add or subtract. That's not going to be the case this time. You have to make them match. So you can multiply one equation, and that works sometimes, and I'll show you when it works. Or you have to multiply both equations, and if you're not sure, multiplying both equations always works, no matter what. You can multiply both equations, and it's going to work out, okay? Sometimes it's just more work than what you have to do, but if you're just unsure, you can always use that method. Remember, if you have opposite signs in your matching coefficients, you're going to add. If you have the same sign, you're going to subtract. Okay, so we're going to use this information to work through some examples. As always, I ask you to write these steps down, write the examples down, give them a try, and then use them to work in your Math Excel assignment. Okay, here's our first example. If you look at your x's, we have a -8 and a 4, and our y's, we have a -1 and a 2. So the x's aren't matching and the y's aren't matching either. Okay, so we have to decide if we need to multiply by one equation or multiply one equation by something or both equations by something. So what you do is you look at the x's, you have a 4 and an 8, and we're thinking in terms of multiplying whole numbers, okay? So can we turn an 8 into a 4 or a 4 into an 8? Yes, we can turn a 4 into an 8 by multiplying by what? 2. Good. Then you can look at the y's. We have 1 and 2. Can you turn a 1 into a 2? Yeah, by multiplying by what? 2. Good. So you can pick. You can do the x's or the y's, but you have to pick one. I'm going to pick the x's. So that's what I'm going to box or circle. I recommend that you do that to help yourself stay on track. So if I look at my coefficients, I have a -8 and a +4. Okay, which one of those do I need to multiply? Good, 4. And what do I need to multiply that 4 by? 2. Good. So I'm going to do that first. So 4x times 2 is 8x. 2y times 2 is 4y. 28 times 2 is 56. Okay, I'm going to bring that top equation over. So I have -8x minus y equals -16. Now, I have matching coefficients and I'm ready to move on. So again, I said I'm working with my x's, so that's what I'm going to box. Do I have opposite signs or the same sign? Opposite. Opposite means we add. So remember, we're going to add everything top to bottom. -8x plus 8x cancels. -y plus 4y is 3y. Okay, forgive me for that pause. As I was thinking through this, that answer is really not going to work out for us. I realized that this should be a positive y. I do apologize. I think I just wrote it down wrong. So when we add those together, this shouldn't be 3y. It should be 5y equals 40. Then you divide by 5, and you get y equals 8. So there's part of our answer. Okay, now go back to one of your original equations. You're going to plug 8 in for y and solve. So just like before, after you multiply, everything is like what we just did. So if you were struggling with 17a, you're getting to practice it a little more today as well. So I'm going to go back and I'm going to use this negative 8x plus y equals negative 16. And remember, I changed that to a plus because I'd written it down incorrectly. All right, so I'm going to take this 8 and I'm going to plug it in for y. So negative 8x plus 8 equals negative 16. Subtract 8 from both sides and get negative 8x equals negative 24. You divide by negative 8 and you get x equals 3. So we have a 3, we have an 8. So our final answer is going to be 3, 8. Oh, sorry. There you go. Okay, here's example number 2. We're going to work through it the same way. We have negative 7x plus 7y equals 21 and 2x minus y equals negative 4. Okay, so as you can see, our coefficients are not matching. So we need to decide if we can multiply one equation by something. So let's look at our x's. We have 7 and 2. Can I multiply 7 by something and get 2? No. Can I turn 2 into a 7? No. Okay, on the other one, I have 7 and 1. So can I turn a 7 into a 1 or a 1 into a 7? I can turn a 1 into a 7 by multiplying by 7. So my new equation on the bottom will be 14x minus 7y equals negative 28. And then I'm going to bring that top equation over. So negative 7x plus 7y equals 21. Now, it just so happened that on these two examples, that bottom equation is the one that I'm multiplying. That doesn't always happen. You could have to multiply the top one. But again, if you can't decide which one, you can always multiply by both. And I'll show you how to do that next. Okay, so now we have our new system. So we decided that we were changing the y's. So that's what we're going to look at over here. Do we have the same sign or opposite signs? Opposite. So opposite means we add. So negative 7x plus 14x is 7x. 7y plus a negative 7y cancels. And then 21 plus a negative 28 is negative 7. Then we divide both sides by 7, and we get x equals negative 1. Okay, so now we have our x. We're going to take that. We're going to pick one of our original equations. We're going to plug this back in and see what we get. Okay, we used the top one last time, so I'm going to use the bottom one this time. 2x minus y equals negative 4. I'm going to take this negative 1. I'm going to plug it in for x. So it's 2 times negative 1 minus y equals negative 4. I know 2 times negative 1 is negative 2 minus y equals negative 4. Add 2, and I get negative y equals negative 2. I can't leave the negative with the y, so I need to divide by negative 1, and I get y equals 2. So now I have my x, I have my y, and my final answer is going to be negative 1, 2. Okay? Now, so both of these equations, both of these systems, we just had to multiply one equation by something to make the coefficients match. Okay? Some of you will be able to see that really easily. You'll be able to see which equation to multiply by. Some of you, it might be a little more difficult. And if you have trouble seeing that you can just multiply one equation, don't even do this. Do what we're going to do next in example number 3. Okay, here's our next system. Negative 7x plus 5y equals negative 12, and negative 9x plus 8y equals negative 17. So if we look at our x's, we have 7 and 9, and our y's, we have 5 and 8. So can we turn a 7 into a 9 or a 9 into a 7? No. Can we turn a 5 into an 8 or an 8 into a 5? No. So that tells us that we're going to have to multiply both equations. So I'm going to go ahead, I'm going to put both equations in parentheses with a multiplication dot. So I can remember I'm going to multiply both. And this is what you're going to have to do. Just pick a variable. Choose x or choose y. It does not matter. Pick whichever one you want to. Sometimes you might want to look at the signs and see if the signs help you make a decision. You can pick the lower numbers. You can pick whatever. For this one, I'm going to look at the y's. Okay. So I have a 5 on the top and an 8 on the bottom. What's 5 times 8? 40. Okay, so I'm going to turn these into 40y. Okay, so 5 times what is 40? 8. 8 times what is 40? 5. Okay, so I just crisscrossed these coefficients. So the variable that I picked, I just took that top coefficient, put it on the bottom, bottom coefficient, and put it on the top. So we just crisscrossed those coefficients, okay? And you can do that every single time. You don't have to think about what you have to multiply by. You can just pick the variable and crisscross those coefficients. All right, so now we need to get our new system. So negative 7 times 8 is negative 56x. 5y times 8 is 40y. And then negative 12 times 8 is negative 96. Right? On the bottom, negative 9x times 5 is negative 45x. 8y times 5 is that 40y again. And then negative 17 times 5 is negative 85. Okay? Now, we said we were looking at the y, so I'm going to go ahead and box those again. And in that box, do I have the same sign or opposite signs? I have the same, so that means I'm going to do what operation? Subtract. Okay, so negative 56 minus a negative 45, that's the same as doing negative 56 plus 45, and that gives us negative 11x. Our 40y's will cancel, and then we have negative 96 minus a negative 85, which is the same as plus. That gives us negative 11, or there's not an x there, sorry, just negative 11. All right, so now we divide both sides by negative 11, and we get x equals 1. Okay, so there's our x. Now we're going to take that 1, we're going to plug it back into one of the original equations and solve for y. You could pick one of these, but they have bigger numbers. Usually one of your originals is going to be easier to work with, so that's why I always go back to the original. So negative 7x plus 5y equals negative 12. I'm going to plug that 1 in for x. So negative 7 times 1 plus 5y equals negative 12. Negative 7 times 1 is negative 7. I'm going to add 7 to both sides, and I get 5y equals negative 5. And if I divide both sides by 5, we get y equals negative 1. So we have our x, we have our y, and our final answer is going to be 1 comma negative 1. Okay, so the difference here is we just picked a variable, we crisscrossed those coefficients and made a new system. Then it was ready for us to add or subtract. In this case, we did subtraction, got our first variable, plugged it in, solved for our second variable. So again, after you get your new equations, it's the exact same process that we were doing in our last lesson. Okay, here's example number 4. All right off the bat, we see that they don't match. We can't turn a 10 into a 14 or a 14 into a 10. Same thing here. So you're just going to have to pick a variable and crisscross the coefficients. So we use y up here. I'm going to use the x's. All right, and so I know I'm going to multiply both. So I have a 10 on the top. I'm going to put it on the bottom. I have a 14 on the bottom. I'm going to put that on the top. I know I have negatives here, but I don't like to multiply by negatives. I would rather just multiply by a positive and leave it as is. If you multiply by the negatives, you'll still get the same answer as me in the end. So, negative 10x times 14 is negative 140x. Negative 10y times 14 is negative 140y. And negative 20 times 14 is negative 280. On the bottom, negative 14x times 10 is negative 140x. Negative 14y times 10 is negative 140y. And then negative 28 times 10 is negative 280. So what do you notice about these two equations? They're exactly the same. Exactly the same. So you could stop here if you can see that and you know what it means. Everything is exactly the same. So that's going to be infinite solutions. Okay. But if you didn't see that, let's go ahead and work through it, and I'll show you what I mean. We have matching coefficients on x and y. I circled the x's before, so that's just what I'll work with here. I have the same sign, so I'm going to subtract. And we know subtract a negative changes to plus. So I'm going to change all of these to plus because they're all negative. So that negative on the outside just changes the signs. And I'm just going to add. Those cancel, and I have 0 equals. Those cancel, and I have 0. We know 0 equals 0 is true, and so that makes infinite solutions. Okay, here's example number 5. 2x plus 3y equals 20. 3x minus y equals 8. We don't have matching coefficients. And then this one is a little bit different. Here we have a 3 and a 1. So you can do this one. You can turn that y into a 3 by multiplying the bottom by 3. But if you didn't see that right off the bat, you might have stopped at the x's and just decided, I'm going to multiply both. And I'm going to show you here that even though we could really just multiply the bottom equation by something, we're going to multiply both equations and we're going to use the x's and we're still going to get the same answer. Okay, so I'm going to say multiply both. I'm going to use the x's. So I have 2 and 3, so I'm going to put a 3 on the top, a 2 on the bottom. So I'm going to multiply the whole top equation by 3. 6x plus 9y equals 60. On the bottom, I'm going to do by 2. So I get 6x minus 2y equals 16. Now, I'm going to box those x's again. And do I have the same sign or opposite signs? I have the same, so that means I'm going to subtract that bottom equation. 6x minus 6x cancels. 9y minus a negative 2y is 11y. And 60 minus 16 is 44. Okay? And now I'm going to divide by 11. Sorry, got a little sidetrack there. And y equals 4. All right, now I'm going to choose one of my original equations. I'm going to plug this number in for y and see what I get. So this one, I'm going to use the bottom equation. So 3x minus y equals 8. I know y is 4. So that's 3x minus 4 equals 8. Can add 4 to both sides and get 3x equals 12. Divide by 3 and x equals 4. Okay, so my x, my y makes my final answer 4, 4. Okay, we just have one more example, and so I'm going to fit it down here in this little section. So 4x plus 2y equals 7, 8x plus 4y equals 0. And if I look at these, nothing matches, and I've got 4. I can turn a 4 into an 8. I can turn a 2 into a 4. So I can multiply this top equation by something, or I could do both and swap them, or swap the coefficients. We can do it in a number of different ways. But the easiest here, if you notice, we can turn a 4 into an 8 by multiplying by 2. And we can turn a 2 into a 4 by also multiplying by 2. So I can do either variable there. So I'm just going to multiply this top equation and see what happens. So 4x times 2 is 8x. 2y times 2 is 4y. And then 7 times 2 is 14. I'm going to go ahead and bring over that bottom equation, that 8x plus 4y equals 0. And what do you notice here? The left sides are the same and the right side is not the same. So that's very, very similar to what we did up here. But here, both equations were exactly the same. They were identical. Here, the only thing that's different is the solutions. So let's see what happens. We have the same sign on both variables, so we're going to subtract. That cancels, and we get 0. But what's 14 minus 0? 14. So this can't be infinite solutions. What's it going to be? No solution. Good. All right, so we've worked through 6 different examples to show you how you can multiply one equation by something or both equations by something. Remember, if all else fails and you're not sure what to do, multiply both equations. So pick a variable, swap those coefficients, and multiply. Okay, and then everything else is exactly like we did back in lesson 17A. All right, I know I moved through these quickly, but you do have the ability to pause, and rewind anytime you need to. Use these examples to work on your Math Excel. If you have questions or need help, please let me know. You can hit that Ask My Instructor button or hang back in the Google Meet and chat with me. Have a great rest of the day.